Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting tonight will be an improvement on how to reduce the current consumption of motor loads. So I got here a small motor load. It's plugged in over here. Okay. And the power supply of this one is plugged into this kill emitter. It's plugged into another outlet, and that outlet is plugged into a live outlet. So right now, the small electric fan, which is a motor, is actually operating. This will be an improvement on the consumption of the current, because I have determined that if I will add one more power factor corrector gadget in parallel with the load, actually we are improving the power factor. Okay, let's try to start with the load without the gadget. So I'll remove this gadget here. Okay, and let's try to see the power factor of the motor with no gadget. It's just the motor, no gadget yet, right? The power factor right now is 0.69. Okay, I will try to toggle this one. That's the applied voltage. The current consumption is 0.16. True power 13.8, 19.9 apparent power. That's the frequency. And the power factor of the electric fan motor load without the gadget is 0.69. Okay, let's try to plug in the two gadgets, okay, in parallel with the load. So I will be plugging the first power factor corrector. Okay, it's plugged in. And I will plug in the next one. So right now, I got two power factor corrector. First one, second one, this is the load. So they are all in parallel. Okay, they are all interacting. And as you can see it, the power factor of the circuit now with the two gadgets inserted is 0.79. So it increases by 10%, 10 points, from 0.69 to 0.79. So really, this power factor gadget actually really works. It's 0.79, right? And as you can see it, if we try to toggle this one, that's the applied voltage. The current now was reduced from 0.16 to 0.14. That's the true power. That's the total apparent power. Actually, originally, this 17.7 or 17.5 without the two gadgets is actually 20. So the total apparent power actually decreases by around 2.5. So that's an improvement. Okay, I will try to toggle one more. That's the frequency. And right now, the power factor of the motor load is 0.79. It got more efficient now. Okay, originally it was 0.69. It goes to 0.79 with the addition of the two gadgets in parallel. So I think the remedy of this one is if we add up more gadgets in parallel, actually we are increasing the power factor and we are decreasing the current consumption of the motor. That's power factor correction. Okay? Oh, that's 0.79. Okay, I will try to remove the two gadgets and the power factor is 0.69. Okay? So to increase the power factor and to lessen the current consumption of this motor, we can plug in the first gadget, second gadget, first one, second one, they run parallel. So right now, the power factor rises up to 0.79. So this power factor corrector from Amazon really works. Hallelujah. Okay, it's 0.79. So maybe the next time around, I will try to buy 4 more like this. And I think I could reduce the current consumption of this one to, if I could reach this 0.79 to unity, much more the current consumption will be lesser. Okay, so the key to the reduction or increase in the power factor and the reduction of the current consumption is actually to add more gadget. So maybe the capacitor inside is not so much to correct the frequency, to correct the power factor. So if I add one more, okay, two capacitances in parallel actually improve the power factor to 0.79. Okay? So what I have shown you, I have increased the power factor from 0.69 to 0.79 by using two power factor correctors. Good evening from Los Angeles. This is Professor David J. De Los Reyes. What I have shown you is that to increase the power factor, we add up more gadgets in parallel with the load. Okay, to increase the power factor and lessen the current consumption of any load. And if we try to lessen the current consumption, of course, we are decreasing our utility bill. Good evening from Los Angeles. This is Professor David J. De Los Reyes.